So we are actually not Orlando's, we are Florida's first ever autonomous racing team, more like a club or group. And we are so excited to have started this. It's been my plan for a long time. By the way, my name is Nitish. I'm a doctoral student at UCF in computer engineering department. My research is mainly focused around autonomous systems and making them safer using real-time systems. So as these systems, autonomous systems are kind of very safety critical, anything goes wrong, it's catastrophic, right? So we need to make sure that everything that goes onto this platform is responding in the correct time. Let's get started. So as I said, we are primarily autonomous racing team. We will be building, collaborating, and developing all these cool platforms like robocars, 110 scale, 116 scale, and then maybe if we get to that level, we will be soon competing like a full-size car at some of the very nice challenges that came out recently. One of them is called IndyAutonomousChallenge, and the recent winner was University of Munich, Technical University of Munich, and they won $1 million, I think $1.5 million prize for this challenge. It was like a proper F1 style race, but autonomous. So I can't wait to see us there. That's my personal goal with this little club that we have now, right? So also, if you haven't already, please follow us on on Twitter. That's our handle. And then I'm sure you guys are already on Discord. Also, please don't forget to sign up on the website. That's the first link that you'll see. That helps me in knowing what areas you belong to, what skills you have, and what you are really interested in contributing to, so that we can map. When we are mapping teams, we know who should be placed where. That will really help us. So I would appreciate if you can go and fill that. Other than that, let's get started. So, okay, I need to click. Okay, so the mission of this club is to create a community for all the self-driving car, for all the autonomous racing enthusiasts. I can already see like we are about 30 people now on Discord. That is surprising for me. I didn't expect that. That's pretty exciting. So we are growing, and I'm sure we'll grow quickly. So this community is the prime goal is to have like a learning experience for everyone. So we collaborate from different domains. We have people from mechanical, electrical, and computer engineering, computer science, and I'm not sure, even more different domains. I have seen people from finances interested in this technology, and they start from scratch, and they are doing pretty well. So our goal is to create a beginner-friendly environment so that anyone who is interested finds an easy entry to our group. So that's why as I'll discuss later, as Mishi will discuss later in this presentation, we'll be hosting a lot of workshop and info sessions in this club, so that we all can get started and reach us at a common place where we can learn equally from each other. Also, I expect as we are growing, I already see it on Twitter and other platforms. So we are being followed by the community, top pages from the community, like robot operating systems, and then we are followed by UCF engineering and some professors, and also we are followed by DIYRobocars and other cool community groups that we have. And it's really motivating for me to see that coming through. So now our mission is also for the beginners, for like the students that are just coming into the university, to help them start with this technology right from the start, and then they can build their resume, their profile, and add more projects related to whatever they do in this club, right? So other series of goals that we have is solve research problems, is solve open problems that we have in research. you will be surprised how many research problems we still have. I know you must have heard that we have autonomous vehicle in certain cities, they are driving nicely, but there are, you won't believe, there are so many different challenges that we are still facing, the research community is facing, the academia, industry, everyone. So the goal of these communities, these club, is to collaborate, is to exchange information, exchange knowledge, and build a system that helps everyone move ahead in this industry. So we are solving kind of a common problem, but we are using our own expertise, our own understanding of things to build things, right? Also, one of the very important thing that our mission is to host autonomous races around UCF, at UCF. So we have some tracks, I know, around UCF that we can talk to department, talk to university, that we can, if we can host our races over there. Until then, we'll be meeting in the UCF. I'll figure that out in later time, but yeah, we'll be hosting a lot of races. We'll be building these robocar platform which are autonomous, and then doing head-to-head races, time-lapse races, all those cool things. So this also helps us bring out the best of, you know, the talents, the contribution that we have, and participate in global challenges like F110, which we'll see what it is in next slide, I think, and the one that I mentioned previously. So this will help us participate in challenges like those, and possibly win them. I can't wait to see that either. So our motivation is that self-driving cars are becoming a reality. It all started in 2005 with this competition that is held by DARPA, and they started this challenge for autonomous kind of racing, but it was too slow, so it doesn't seem like racing. But anyway, so the last challenge, the last DARPA challenge was held and was won by Stanley, which was Stanford's autonomous vehicle, and it was advised by a very popular person. His name is Sebastian Thrun, and he's right now a founder of a flying car company called KittyHawk. So I'm sure you must have also heard of Udacity. He's founder of Udacity. So that's where it all started. It transitioned to Google Car, the self-driving Google Car. It used to be called earlier, then they renamed it to Waymo. And that's a pretty successful platform. They have their autonomous vehicle being tested over all over the US. I have seen some of them running around Detroit and Novi area in Michigan. So, and also recently there were some cool demos from Cruise Automation in which they are driving autonomously in California. As I said, there are so many different challenges still to be solved. The future of autonomous driving somewhat looks like we don't have any steering at all. We don't have to drive the car. The car drives us itself from A to B anywhere we want. That's the goal, and will not feel the need of owning a car by then. So that's like a fleet of robot taxis always on the road, and they don't have to park because there are always people going from somewhere to somewhere. So we will save parking spaces, all the infrastructure. So many, there are endless advantages of self-driving cars. I can go on. So now this is like the industrial approach of solving this problem. But some years ago, a community decided to take this to themselves and started this meetup called DIYRobocars, which is so cool. They built this different scales of racing cars, and then they compete in some area, and they have like tracks and everything. It's like a growing community, and they are all over the world now. They have meetups all over the world, even in Japan, India, China, and everywhere actually. So then there was another 1/10 scale car, which was also a racing platform by MIT. It got a lot of popularity because they released their kit, and everyone was developing those. So that was the next step. And then now we have IndyAutonomousChallenge, which are real F1 cars participating to race autonomously. And then we have F1 tenth, which is like 1/10 version of racing cars driving autonomously and racing. And this is something that I participate in. I have participated in recent races. So basically, there is a huge boom of this technology and everyone wants to get into it. And these are just some of the companies that are already in this, this domain, and there will be more and more and more. Even the University of Munich, who won the IAC challenge, they spin off a new company, I think Drive Blocks, something like that. I'm not sure about the name, but yeah, so yes, it's the opportunities in this domain are endless. So what is autonomous challenge? If I ask someone, the default answer is usually a car that drives itself and doesn't need any human. But the question arises, for how long can it drive itself before it fails something at something, how stable its system is. And another question is where it drives. Does it drive everywhere? Does it drive on highway or a particular city or a particular area? So all these companies that are developing this, these technologies, they are focusing on small domains to start with, like they call them ODD, operational domain. And it's like the system is only designed to drive over there, and they collect data, they drive for like all the time, to collect all the data. So this really helps in, because there are some rules from NHTSA that before a car can be said as an autonomous, it needs to pass certain number of miles and so on. So this system is obviously safety critical, as we all know. If something fails, it's not good for anyone inside or outside the car. So this is a very important criteria for this technology to be successful. If it's safety critical, we need to address all the safety issues associated with the cars. Now, there are some levels of autonomy that are defined by, I think, primarily by SAE organization, and those are like one starts with 0, but yeah, 0 is like no assistance, nothing. It's just a car and you drive it entirely. There's no help from the car to you. So, and then it kinds of increases in modularity and what kind of assistance you can get with each level. And the level 4 and 5 are really the ones that can be said fully autonomous. Up to level 3, we already have a lot of companies doing stuff. You can sit in your car, it can steer itself and accelerate itself, deaccelerate itself, all those things. That's already being done. There are some companies like Cruise, I would say. They are level 4, but they are not completely level 4 because they will fail in some other scenarios, which it is not designed for. So those are the levels, and the goal is to get to level 4 and 5, eventually 5. So why racing though? We have autonomous vehicle, but why to do racing? Racing presents more challenges than just running a car in an urban environment. Racing gives us high-speed dynamics, which are very important, because to model your algorithms to handle those high-speed dynamics is extremely challenging, and a lot of people are working in this area, and that's why we have all these competitions coming up for autonomous racing. So if we can solve high-speed dynamics, it will help us to build better autonomous vehicle, basically. So now with high-speed dynamics also comes response time, which becomes more and more critical. So each software stack, each module need to be designed in such a way that it responds in a bounded amount of time. It cannot take more time than that. So it needs to guarantee some response time on which it will give us a like an output. Then of course we are crazy people, and that's why we want to do autonomous driving, autonomous racing. So this AV stack that is kind of very common, that you'll see everywhere if you Google autonomous driving stacks. These are the 3 main modules that go inside an autonomous driving platform. One of them is perception. This is where all your sensors give you your data. And so by sensors, I mean, you have LiDAR, you have cameras, you have depth cameras, you have ultrasonic sensors. These are all long range and short range sensors that go on an autonomous platform, and then they give out data. These data is then processed and then given to perception module to make sense of it. The data that you're seeing, what it is it a human or a car or a building, you know? So those kind of decisions are made under the perception stack. So there is also mapping that goes inside perception, which kind of maps your 3D data, which is given by the LiDAR, along with your camera data, and that helps in recognizing the object. So that's perception module. And then we have a planning module. This planning module is responsible to create a set of waypoints that your car needs to follow. There's also a behavior planner that goes inside planning. Now the task of this behavior planner is to handle certain situations that arise in autonomous driving, urban driving. So scenarios like what you need to do when you see a certain traffic sign, what you need to do when you see a certain traffic signal, and things like that. What if you see a pedestrian suddenly in front of you, what you need to do? All those things are being handled by a behavior planner module. Then you do obviously path prediction. So where your car wants to drive, you spit out your waypoints, which is basically set of points that your car will be on in the future, and also like things like velocity profile, what velocity you need to be on when you reach that point, things like that. All those things are outputted by your behavior planner. Obviously, it takes the information from your perception module. Now, all this goes, the waypoints and the velocity profile, these things go to your control module, where there is a control algorithm implemented, something like a PID control, which you might have heard of, or like a model predictive control, more advanced control optimization algorithm. There can be others. So the purpose of control algorithm is to kind of make the car drive on the path that the planner gave, right? It's not as easy as you would think that, well, you have the points, you just need to drive, but there's a lot of challenges, as we'll see when we work on these modules, right? So the control module gives out a velocity and a immediate velocity and a steering, we can say, like in here we can see that it gives out acceleration, then braking signal, and then steering signal. So depending on how your environment is configured, we can have different kind of signals being outputted by the control module. So it's like a software stack. But other than the software stack, there's a lot of hardware design, and then the mechanical design, stability analysis, things go in this technology, right? So it's not just, this is from a software perspective. So let's move to next slide. With this club, there are endless opportunities for everyone at UCF, like for students from mechanical, aerospace, engineering, electrical, electronics, and computer science and computer engineering students. We all have opportunities to collaborate and learn. It's not possible to build autonomous vehicles without one of these domains, basically. So here are some of the tasks, or I would say like areas that may be associated with each branch of engineering. So we have vehicle dynamics and modeling from the mechanical perspective. We need to have like a CAD design for, if we are talking about robocars, we need to have like a proper CAD design and structure to hold all our components in place, right? And yeah, and also we need to make sure that while we are doing this, the stability of the car remains intact. It doesn't flip over, because remember, we are doing high-speed racing, right? So after that, there's also a lot of integration and assembly things go from the mechanical perspective. Okay, so from electrical and electronics perspective, we have circuit designing, we have embedded systems, we have sensor integration. We will, as I said, there are so many sensors that go inside autonomous vehicles. So those, and then we have power supply management, whether each of the components getting the desired power, desired input, right? And then For communication, we have like embedded platform communicating with your software, maybe remotely, like ROS. ROS is majorly a communication framework for robotics. So for computer science and engineering, it will be very exciting because we have a lot of software development around whatever hardware that we have. We have, for instance, computer vision that goes inside this, as we have cameras and LiDAR, so 3D computer vision and computer vision, everything. We have machine learning to make sense of the data that is being outputted by the sensor, like classification, segmentation, recognition, all those things. So can be also done with deep learning. We have YOLO, for instance, for detecting obstacle around the car. So some of the approaches also use reinforcement learning, where you directly give your sensor data to your learning algorithm, and it outputs your desired control signals, right? So one of them is AWS, and there are more. So we have all these kind of areas to work on. So we have something for everyone, basically. I can hand over to Mishi now. I think she can discuss upcoming slides. She's a part of our committee, and welcome, Mishi.
Hi, thank you so much, Nitish. All right, everyone. So we've discussed a lot about what autonomous vehicles are, what our motivations are. Now you all must be wondering, what's in it for me, aside from all the opportunities that Nitish presented to you all previously. So what we all have planned for you are a plethora of fantastic projects and ideas that we are working to become a reality. So there are a couple of things that we have ready for you all, which is we want to have our team members originally work on the 1/10 scale race cars, and this involves designing it, this involves finding parameterizations for it, this involves integrating multiple systems, this involves working with the platforms that these kind of cars are working on, such as the F-110 has a specific gym associated with it, for example. We'll be eventually taking what we've learned from these races hosted by other people, and we want to implement our own races here at UCF with everybody who wants to join, with your own cars that we'll be talking about later on in the future. Additionally from that, a lot of other things that we have planned include hands-on workshops. This is more friendly for beginners, especially if you aren't familiar, you're interested, and you have some things that you want to look on. These hands-on workshops are for you. We also have other projects, including the robot arm that'll be Nitish has more of a foot for that. I'll pass it on to him if he wants to talk about that. And other things that we have includes working with teachers and staff and experts from all of fields that we are connected with to go ahead and talk with us. We eventually have an idea that we want to extend to multiple scales, in the sense of we want to reach out to multiple domains. We want to work with other departments within UCF themselves to go ahead and make this something big, make this something that we can really outreach to others around. So this is only a taste of what we have in store. Nitish, is there anything you want to add, anything that I haven't covered that you would like to talk about for our plans and future projects?
I think you talked about almost everything. So we'll have multiple scales of these cars in the future. For now, we have a 1/10 scale, which we can start working right away. I have like a decent startup kind of structure for that car right now. So I have all the circuits and all the components that we might need to start developing. So yes, I'll move to next slide for Mishi.
Yeah, absolutely. So for this one, we'll go ahead and so something special that we wanted to announce from the beginning. Nitish and I are absolutely, and Sanjay as well, we're so floored to have gotten this kind of recognition. We are officially recognized by DIYRobocars. Nitish, go ahead and elaborate a little bit more as to why this is such an immense opportunity for us.
So as I said, DIYRobocars is like a huge community in autonomous racing. They started a while ago, and it was started by a person named Chris Anderson, and I think I got his name correct. So he's now COO of KittyHawk, which is the company Stanley's advisor created also Udacity's founder. So so as you can see, this community is so well connected. Everything is so well connected. So DIYRobocars has featured us on their Teams page, so you can find our link over there. So what this means is basically we can use their resources, like their build instructions, their maps, and everything that they do. We can use that officially in our races. We can host the races in their way also. So that's I'm so happy about that. And also, along with DIYRobocars, we are getting attention from other groups from the community, like F1 10th and Ross. So I'm sure we'll soon collaborate. We'll soon be able to collaborate with them also. So as I said, DIYRobocar is a large community. This is like one of their tracks. They started in California a while ago, and yeah, now they're all everywhere, all over the world. These are some of their. So the good thing about this is like a open community, right? So people are free to choose the design that they want to make for their cars. They're not bounded to something like they gave. You don't have to follow their little instruction, but it's like if you want to do less work, you can. Anyway, so that's about DIYRobocars, and pretty excited to be being supported by them. Mishi, yeah, introduce us.
Alrighty, so I'm more than happy to introduce to you all the organizing team that has brought all of these efforts and everything to you all. And these are the people that you will be working closely with as we begin our workshops, our guest lectures, and working hands-on with the little cars and all the other devices that we have prepared for you all. So I'd like to go ahead and take a moment to recognize Nitish. He is currently above me. I don't know where he is for you all, but Nitish is the brains of this operation. He is the one who one day grabbed me and was like, we're going to make this happen. So ever since then, we've been putting everything together. And he is one of the guys that if you want to really connect with a large network regarding autonomous vehicles, reach out to him. Along with that, I'd like to go ahead and take a moment to recognize Sanjay as well. He is a brand new member to the team, and he is another wonderful player to the components. Alrighty, so with that, I'm going to go ahead and grab that and say, as you all have heard, I'm Miche. I work as well as I'm Nitish's research assistant, and I work in the RTIS lab as well. So I have a lot of familiarity with autonomous vehicles. That's all I've been doing my research ever since I've started my college career. I have a lot of familiarity, for example, with the MIT race car projects that Nitish mentioned in the first slide, and along with F1 10th, I've been here for about 2 competitions now, and I'm looking to be here for more with you all as well. So that is the organizing team. I want to take a moment to also say, please reach out if you want to help coordinate anything, if you want to help volunteer, if you have any ideas they want to bring up to us. We are very much open to bringing something up and running. We are here for you all in case you all want to get connected, in case you all want to start racing already. We can make that happen. That's our goal, but with your help, we can make it a reality. So now we'll go ahead and discuss the upcoming workshops. So as I mentioned before, we have some workshops in the running, and some of those specifically are built for our beginners. So some things, for example, we are very much friendly to everybody. We're not just working with computer engineers who may be familiar with GitHub, who may be familiar with Python. The robot operating system, also known as ROS, is a very frequented system found within these kind of cars. So we want to go ahead and have a workshop, a place where you all can go ahead and jump around with this, play with it, understand it. We're here to guide you all through this. So for example, we have Python. That's a Python workshop that we have, Kickstart Python for Robotics. That's where we're going to go ahead and have everybody hands-on, sit with us, with experts, and build your own game. So once you walk in, you may walk in not knowing anything Python related, but you'll walk out with a game and more knowledge. Aside from that, as I mentioned previously before, we'll be getting you all started with the robot operating system, also known as ROS. It's a pretty complicated architecture if you see it from up far, but once you sit down with others and understand it, it really does become it becomes easier, and it becomes really fun as well. So
Don't
Another
worry,
one that
make it,
oh, go ahead.
we
Yeah,
will make it easy for you. So the workshop will be
absolutely.
designed in a way that everyone understands them. So
Absolutely. And from there, we also have the basics of GitHub. That's what we're going to be discussing Git along with GitHub. And we have named it Go Go Git. So these are just some of the few that we have upcoming. Please watch out for the dates and the times for this. And we will be discussing if we're going to make it virtual, we're going to make it in person. Please watch out for more details on that and let us know what you think. Let us know if there's anything you want to focus on, anything you want to look into. We are here for you once again.
exactly, we are pretty open for suggestion. We are new, and we are also learning along with you. So please let us know if there is like any suggestion that you have for us, and any questions that we can answer, of course. And for the next thing that I would want you to do is go ahead and fill out that online sign up form that I have on the website, so that I understand in which team you would want to work in. We'll be soon or dividing our entire pool of members into teams, and have them work on their desired area. So please do that. And for the upcoming the info sessions, the workshops, I'll be sharing the timing details. It's probably going to be next week. I'll share the meeting details for that. Other than that, will be so these kind of meetings will primarily be for us to share our knowledge with each other. Other than this, we'll be having like we'll be meeting in person to work on the actual platform, and kind of brainstorm ideas, and collaborate over there. So details about that will be again shared on Discord, and I would like to know your preferences for organizing that, because I'm sure you guys are pretty busy with your schedule. So I don't want anyone to miss anything. So please also be active on our server. So it was so nice to see you all in this presentation. I'll stop sharing the screen. Thank you so much.